What we're going to also talk about on the back of the page is we're going to factor first, and then we're going to use our factored form to state any restrictions that we might have. The students get confused here, but I'll try and explain. So what I do know is that in math, there is a rule that you are not allowed to divide by 0. So if you type in 6 divided by 0 on your calculator, you get an error. We cannot divide by 0. So because it gives us an answer that is undefined. So we cannot ever have 0 in the denominator. So we're going to go ahead and do these questions exactly like we were doing on the front of this page. So I'm going to factor first. Factor first. We have to always factor first. And I'll explain more in a minute what these restrictions might mean. So this is a simple trinomial in the numerator. I've got to think what multiplies to give me -6 and adds to give me 1. So I'm going to think about having m's in the front of my brackets. What multiplies to give me 6 is 2 times 3. And if the 3 was positive and the 2 was negative, I would get +1. And then the denominator, what multiplies to give me 8 and adds to give me -6. 2 times 4 is 8. So if I had a -2 and a -4, I would get -6 if I add them and +8 if I multiply them. So there is factored form right now. And we're going to do the same thing as we were doing. We're going to, I can cancel those out. Isn't that awesome? And so my final answer in simplified form would just be m plus 3 over m minus 4. But there's an issue here. At any point during my solution, when I had factored form, I notice 2 brackets that are really important. And I'm thinking in the denominator at any time, if this m here had been a 2, 2 minus 2 would have given me 0. I can't have 0 in the denominator. 0 times anything is 0. It would have given me 0 in my denominator, and I'm not allowed to divide by 0. Same thing here. If that m had been a 4, 4 minus 4 is 0. I can't have that. So my restrictions, I know that this one has been canceled out. So for sure the m minus 2, that's a really big deal. So I don't know. This sometimes doesn't make sense, but I know m minus 2 can't equal 0. So if I solve that like a little equation and I move the 2 over, m cannot equal 2, which should make sense when you put it here. If that was a positive 2, 2 minus 2 is 0. That can't happen. As well, the m minus 4 cannot equal 0. That bracket can't equal 0 because anything times 0 is going to give me 0. So that means m can't equal 4 because I'm going to think about moving this -4 over. Imagine that the 4 was there. 4 minus 4 is 0, and that can't happen. So the rule is for some teachers anyway, since this m minus 2 canceled out, I'm going to say a little comma where m cannot equal 2. That's my restriction, it's called. So we use factored form to state restrictions in the denominator. We must state those that are not obvious in my answer. Some teachers would say that I don't need to say that m can't equal 4, because I can see right here in my answer still that m can't equal 4. What I don't see in my answer is that m can't equal -2 because it was canceled out earlier in my solution. So a lot of teachers would say, this is all you need to say. Some teachers, I don't know, it depends on the person. I don't usually require or give marks for somebody that also says m can't equal 4. I can see that in my answer. Some teachers, maybe your grade 12 teacher, they're going to say, okay, I want you to state all the restrictions. They might say m cannot equal 2 or 4 with a little comma. I'm really just wanting you to for sure say that m cannot equal 2 because it was canceled out and I can't see it anymore. So we'll try another one. I hope that made sense. I tried to explain that and take some time there because I don't want you to get confused by this. If the question says, state the restrictions, I need you to state the restrictions. I need you to say what would have happened to make this denominator become 0 at any time once you've factored. So here I have simple trinomials again. 12 times 4 is 48, and 12 and 4 would give me 16. And then the denominator, 12 times 1 is 12. So I'm thinking, okay, which one's which here? And 12 times 1 is 12. But I have to get negative 11 when I add them, so I'd have to make the 12 negative. And then I notice, ooh, I have this b minus 12 and this b minus 12, and they cancel each other out. So I have b minus 4 and b plus 1 as my simplified answer. So I'm going to say where b cannot equal 12. For sure. I have to say that for sure because I can't see it in my answer. Sometimes a teacher might want you to say -1 as well. So basically we're flipping the signs, right? Think about what we did over here. We ended up flipping the signs because you're trying to solve. So if b minus 12 can't equal 0, that means b can't equal positive 12. B can't equal -1. -1 plus 1 is 0. So I need you to show me this one for sure. It's kind of optional if you want me to show. If you want to show me that one, I can see that b cannot equal -1 because it still remains in your answer. Okay, this one over here, we've got x squared minus 9. That's a difference of squares, so that's x plus 3, x minus 3. And a simple trinomial, it's actually a perfect square trinomial in the denominator. I don't think I'll write it as x plus 3 squared though. I'd like to show both of those. Normally we might just write that as x plus 3 squared. But 3 times 3 is 9 and 3 plus 3 is 6. But I see these cancel out. I have x minus 3 in my numerator and x plus 3 in my denominator. I would say, in my opinion, you don't have to show any restrictions here. I can see that x can't equal -3. But maybe if you want to, you could say x cannot equal -3. Some teachers will require that. I probably wouldn't give you a mark for that because I can see that because it still remains in your answer. What do we have here? Oh, so much better to do trial and error. This one, what I see is that I can divide the numerator by 2, and I'm left with 2x squared minus 3xy plus y squared. And I'm going to just leave the denominator because I don't have a common factor in the denominator. Okay, so like I said, I see a complex trinomial in the numerator and I see a complex trinomial in the denominator. I would factor those over on scrap paper because I would really like you just to go into your factored answer. Otherwise, you're going to have several lines of writing that might take a lot of space. So if you don't want to do this by trial and error, you could do it sort of on the side, and you'd have to use decomposition for these. So I'm thinking I want to make the first terms give me 2x squared. So I look at this first, and I need the back to give me y squared. So that's not bad. Just y times y is y squared. And then if I think about -2 and -1 on the outside and the inside, so this would be -2xy minus another xy. I'm going to get -3xy in the middle. The one down here, I think about the front. I have to make that give me 3x squared. And I think about the back. I have to make that give me y squared. And then how do I get -4 if they're both negative? Right? That'd be -3xy minus another xy. That would give me -4xy. Then I see that these cancel. And that's about all the simplifying that I can do. So I'm going to still have a common factor. And then my denominator, 3x minus y. I do want to state the restriction for sure here. That's a little weird. X minus y can't equal 0. So x can't equal y if I think about the y going to the right. So that's where x can't equal y. If it did, I would have 0. If I put a y in here, y minus y is 0. I guess the other one, 3x minus y, is in my answer. 3x can't equal y. Divide by 3. So I could also say x can't equal y over 3. I don't know. This one I wouldn't really need you to do. This one I would need you to say because it was canceled out throughout our answer. Okay, last question here, because I know that's been a lot. It's a lot of factoring and it's a lot of new things to think about. Example 3, state the restrictions. So that's all it's asking for. It's stating the restrictions. It's not asking you to simplify. It doesn't really want you to simplify. So all I need to do is look at my denominator, and I know that my denominator can't equal 0. So if I just think about solving that as an equation, I know that x can't equal 5. If x was 5, 4 times 5 is 20, minus 20, I'd get 0 in my denominator. It's not asking for anything else, just what would the restrictions be? So I look at my denominator here. I know that can't equal 0. So I could have moved the x over as well. This time, because it's not an inequality, I can divide both sides by -1. So x can't equal 2. And think about that. If I put a 2 in there, 2 minus 2 is 0. So x can't equal 2. And that's just how to state restrictions if you don't have to simplify first.